Okay, on 10.3, we are going to define and use probability. The probability of an event is a number from 0 to 1 that indicates the likelihood that an event will occur. Okay, so if it's 0, the event will not occur. If it's 1, it's certain to occur. If it's 50% or 0.5, then it is equally likely to occur or not occur. Okay, anything between 0.5 and 0 on the low end, less than 0.5, okay, is closer to not likely to occur. Anything between 0.5 and 1 on the higher end is more likely to occur. And that's how you're going to phrase this stuff when you're dealing with it. Okay? Define theoretical probability. Okay? When all outcomes are equally likely to happen, meaning rolling a dice would be theoretical probability because you could roll any of those numbers. You have a 1/6 opportunity to roll those numbers. So when you're doing things with dice, when you're doing things with flipping a coin, those are all theoretical type of probabilities because they all have the same amount of chance of happening, okay? When you do that and you're figuring out theoretical probability, to figure out the probability, you take the number of outcomes in that event over the total number of outcomes. Meaning, if I flip a coin 12 times, the bottom number would be 12. I flipped it 12 times. I got heads 7 times. So the probability of getting heads in that case is 7 over 12. Okay? That's what they're looking for when they do theoretical probability. You do theoretical probability a lot in science. Well, and experimental. You do both. But we're going to talk about experimental in a minute. Okay. So you roll a standard 6-sided die. What's the probability of rolling a 5?
1 in 6.
1/6. Yep, 1/6. You have a 1 over 6 chance. Okay, part B. You're still rolling a standard 6-sided die. What is the probability of rolling an even number?
3.
3 and 6, which equals 1/2. Always reduce down for me. Okay? And in your book, they might change these to decimal answers. If they do, round to 2 decimal places, that's fine.
Why do you think a 6-sided dice is standard?
They're saying, when they say standard, they're saying that means that it has the numbers 1 through 6 on it. It's not like a dice that has 2 2s, 2 4s, 2 6s, or something like that. That's what they're clarifying. Whoa, I'm going to trip and die. Okay. A community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. What's the probability that the musicians perform in alphabetical order by their last names, assuming that no 2 musicians have the same last name?
Well, you probably have to play permutation.
Well, how many singers are there?
7.
7. So in the first spot, how many people could be placed there?
7.
And then
7. 7.
6,
Oh.
and then 5. You were right about permutation. 4, 3, 2, 1, right? However, how many ways can alphabetical work out? 1. There's only one way to alphabetize people.
Oh, okay.
Okay? So the probability of this happening would be the number of outcomes that can happen that way, which in this case is 1, over the total number of options. The total number of options in this case is what? Well, 7 times 6 times 5 times 4, which is called what?
Permutation.
It's that fun little explanation point there. It's a permutation. So what is 1 over 7 permutation? Oh, you turned it into a decimal. Okay, so you get this, right? 1 over 5,040. And you got 0.000, what did you say? I have 3 zeros and then I round to 2. Yeah, 198, okay. Those are congruent to 0.0002. I just rounded it there. That is the probability of randomly selecting all 7 people in alphabetical order. Not very likely, okay? We would say unlikely in this case if we were classifying. Part B. You are friends with 4 of the musicians. What's the probability that the first 2 performers are your friends? You're friends with 4. What's the probability that...
2 out of 7.
Okay, we're going to take 2 out of 7 for part of it, but there's another portion to it. Because you're picking 2 spots out of 7 in the first place, right? So if I have 7C2, because it doesn't matter what combination it's in, what order it's in, what would go on top of that fraction?
4.
Yeah, 4C2, because I have 4 friends and 2 of them need to fill that spot. So if I find the probability of this happening over the probability of the whole thing, I can get the probability of those 2 things being combined. Does that make sense? Okay, so what is 4C2 and 4C7?
6
6.
over 21.
Yep, over 21, which is approximately...
2 over 7.
No, not 2 over 7. Oh, if you reduce it. Okay, I was just going to change it into this. So approximately 0.29. So you have about a 29% chance of the first 2 performers being your friends, if you know 4 of them out of the 7. Okay? These are things that we're looking at. We're combining a couple steps into one. Okay, when people gamble, especially like with the horse races this weekend, or with NBA, you know how NBA has 7 games in the tournament finals. There's a lot of things called odds in favor or odds against teams, or against horses or whatever. Okay, and this is how they deal with that. This is how they figure out what the odds in favor or odds against is. When you're using odds to measure the likelihood of an event, okay, odds measure the chances in favor or the chances against. If you are doing odds in favor of an event, it's a number of outcomes in that event over the number of outcomes not in that event. So, outcomes in that event that you want over not in that event. That's in favor. If you're doing odds against, okay, it's the opposite. It's the odds that you don't want over the outcome you do want. So what you don't want over what you do want is odds against. Odds in favor is what you do want over what you don't want. Okay? And then you can write it in a couple forms. You can write it in fraction form, or you can write it in the form where it's like A to B in this region. So we're going to look at some of those. A card is drawn from a standard deck of 52 cards. Find the odds in favor of drawing a 10. Odds in favor of drawing a 10. How can I do that?
Well, there's 4 10s.
There's 4 10s. Good. What'd you say?
It will be 52 C4. Oh, 52 C4.
No.
It
No.
will be 10.
For odds against and odds in favor. Remember, if I'm doing odds in favor, it's what you want over what's left.
So 4
Over what you don't want. So 4 over what?
48.
48. Because if you do 52 minus 4, you get 48. So it's simply 4 over 48, which reduces down to,
112.
yep, so you have a 1/12 shot at drawing, or odds in your favor are 1 out of 12 of drawing a 10. So another way to write it would be a 1 to 12 ratio like that. Okay, you're going to see it written both ways in your book. On part B, you want the odds against drawing a club. So what are the odds of drawing a club?
4 out of 10. 20. Oh.
What are the odds of drawing a whole suit and club?
Well, there's
14. What's 52 by
Not 14 cards in a suit. 13. So, when I'm doing odds against, I want what I don't want over what I do want. So I want a club, so that goes on bottom. If I don't, what are the numbers of not clubs then? What's left? 39. What does 39 over 13 reduce to?
3 over 1.
So another way to write it would be a 3-to-1 ratio. So the odds against are 3-to-1. So you're more likely not to get what you want than you are to get what you want in that case. Okay? Experimental probability. This is where science comes in a lot. When an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by the probability of A equals the number of trials where A happens over the total number of trials. So what you want over everything. Okay? The bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. How do I do that?
So you do 551 over.
No.
Okay, so you
It says at least 40 years old.
do, so you do 551, 300, plus 300, plus 238.
Good, so add 551 plus 300 plus 238, right?
Over
Good, over what?
463, 1,085, 873.
And
300.
238, because this, when you are doing experiment, is what you want over everything. When you're doing odds in favor or odds against, it's what you want over what's left. Not, so that's the difference. Experimental is what you want over everything. So I'm gonna say 463 plus 1085 plus 879 plus 551 plus 300 plus 238. Okay. So what comes up top? If I add all those up top, you get what? 1,089. And if you add everything on bottom, what do you get?
3,516.
Good, 3516, which then gives us what ratio? Or what probability? Put it into decimal for me.
30.9.
You mean 0.309? Okay, so 0.31 roughly. So about 31% of the people want to be 40 or older. When surveyed and asked, what age would you prefer to be as an adult? Clearly, they surveyed men.
They want to die.
Because men feel distinguished around 30 and 40, you know? Women are like, I'll stay in that 20 range.
Exactly. What am I gonna do once I hit 40? What do I do? You have to be serving the community.
Okay, last problem. Geometric probability. This you should have done last year for me, geometric probability, but let's see what we remember. Some probabilities are found by calculating a ratio of lengths, areas, or volumes. That's your hint here that it's geometric. If you're doing lengths, widths, or volumes, okay? Lengths, areas, or volumes. So, you throw a dart at the square board shown. Your dart is equally likely to hit any point inside the board. Makes sense, you're throwing it at the board, okay? Are you more likely to get 10 points or to get 0 points? So, 10 points is where on that picture?
The middle.
The middle, the yellow portion only. 0 points are what color portions?
The black.
The black. Okay, the black. So, are you more likely to get 10 points or 0 points? How can I figure that out?
Area,
Area of what?
The circle.
the circle, and then the Also the square.
Okay, the area of the circle over the square will tell you the probability of hitting that tiny circle. We also then have to figure out the area of what?
Of the little circle inside.
Zero.
That's what I was talking about in the first place,
Oh,
Alex, was the,
Huh? Well, I mean, if you take this area, 18, 18,
Yeah.
you get the area of the rectangle, and
Yeah.
then you minus it by the big circle.
oh, good, that's what I need you to say.
Okay.
Okay, so to figure out the area of the 0 points, Alex is saying that we take 18 times 18, which is just 18 squared, and subtract from it that blue circles area so that we know what the black portion is, yes?
Yeah.
Okay, so how do I find the area of that blue circle?
Pi r squared.
Pi r squared,
So
so
you
what
got-
did you say was r?
9.
9, 369. So pi times 9 squared over the area of the actual square, okay, will give me the probability of hitting that black portion. So 18 squared is 324, so I have 324 minus what? 81 times 3.14, right? Minus 254.34. So that probability gives me 69.66 over 324, which comes out to be approximately 0.215. So 21.5%. Now, you guys are right. We have to take the area of the yellow circle over the area of the hole. So the yellow circle, what is it? It's pi r squared. What's your r?
3.
So pi 3 squared over 18 squared. 18 squared is 324 still. Then I have 9 times 3.14, 28.26, which is congruent to 0.087. Which one is more likely to hit? The 0 points or the 10?
Definitely. The 0 is on
The
top.
0.
Yeah, that's
Because this has a 21.5% chance if you change it into percentage. And this has an 8.7% chance of hitting. Oh. Okay, which makes sense because think about it this way. Do you see how yellow is like the target, right? And when you're like throwing something at a target, the target's always the smallest part on the board, right? Because it should be the hardest to hit. So that's why that would logically make sense, that that portion would be harder to hit, harder to get 10 points than 0 points. Okay, questions? Okay, let's do your homework.